Good evening, friends. Today we are discussing on formulation of LPP and solve the LPP formulated using graphical method. So the problem statement goes like this. A firm manufactures two types of products A and B and sells them at a profit of 5 rupees on type A and 3 rupees on type B. That means by selling 1 unit of product A, the profit obtained is 5 rupees, and selling 1 unit of product B, the profit obtained is 3 rupees. Each product is processed on the two machines M1 and M2, and the type A product requires 1 minute of processing time on machine 1 and 2 minutes on machine 2. So that is tabulated here. So that is 1 minute on machine 1 and 2 minutes on machine 2. Similarly, the type B product requires 1 minute on machine 1 and 1 minute on machine 2. So that is tabulated here. The machines M1 and M2 are respectively available for at most 5 hours and 6 hours during any working day. So 5 hours means 1 hour 60 minutes. So 5 hours means 60 into 5. So that is 300 minutes. Similarly, machine 2 available for 6 hours. So 60 into 6. So that is 360 minutes. Now it is asked to find out how many units of each type of product should the firm has to produce a day in order to maximize the profit. So more number of units are produced means more profit. So to maximize the profit or to increase the profit, so in a day the firm has to produce how many units of A and how many units of B. That is to be found out. Formulate the problem as LPP and solve it graphically. Now I will consider that X units of product A and Y units of product B are manufactured. Number of product produced cannot be negative. That means X comma Y greater than or is equal to 0. So if I don't produce anything, X and Y will take 0 value. If I produce some products of A and B, so X and Y will take positive value. In no case they cannot be negative. So the statement what is given here is tabulated here. The availability of machine 1, availability of machine 2, and how much time these products A and B are processed on these two machines. Now the constraint of product A and product B and machine hours availability for M1 and M2 will be stated like this. So product A is processed on machine 1 for 1 minute, and product B, 1 unit of product B is processed on machine 1 for 1 minute. So if I produce X number of units, the time spent for product A on machine 1 is 1 into X. Similarly for product B, so that is 1 into Y. So 1X plus 1Y is less than or equal to 300. The constraint is less than or equal to, in the sense the machine time availability cannot exceed 300 minutes. So that's why it is less than or equal to. Similarly on machine 2, so it is 2X plus 1Y. So less than or equal to 360 minutes. The firm manufactures the two products A and B and sells them at a profit of 5 rupees and 3 rupees respectively. So my profit Z will be equal to, okay, for 1 unit the profit is 5 rupees of type A. So if I produce X number of units, so the profit obtained is 5X. Similarly, selling one type of one product of type B, so the profit obtained is 3, and the total profit what I am getting is 3 into Y. So total profit I am getting is 5X plus 3Y. So that has to be maximized. Thus the mathematical formulation of LPP is like this. Maximize Z is equal to 5X plus 3Y subjected to the constraints. So 1x plus 1y less than or equal to 300. Then 2x plus y less than or equal to 360, x comma y greater than or equal to 0. So the LPP is formulated. Now I have to find out what will be the values of this x and y so that I am getting maximum profit. We are taking the help of graph. So here the condition is that 1x plus 1y. So this inequality I am converting it into 1x plus 1y is equal to 300. So if x becomes 0, y value becomes 300. If y becomes 0, x value becomes 300. So the coordinates will be 300 comma 300. So that will be, so x coordinate. So that is the product x, I am marking 300 here. Similarly for y coordinate, so I am marking 300 here. So then joining those 2 points, so 300 comma 300. So then the other constraint is 2x plus y is equal to 360. So if x is 0, y becomes 360. If y becomes 0, x is equal to 180. So that 2 into 180 becomes 360. So the coordinates are 180 and 360. So here on x-axis, so 180 is marked. On y-axis, 360 is marked. So joining the 2 points. So now I have the 2 constraints here. So having the constraint less than or equal to. So I have to consider the area below these 2 lines so that the feasible region is the hatched one, what is shown here with the corner points. So that is 0, B, E and C. So for these corner points, the coordinates are shown here. And I am calculating the value of z for these corner points. So I am getting 4 values for z. Out of these 4 values of z, so 1020 is maximum. So I am getting the profit of rupees 1020. So that is the maximum profit which is obtained at the point E with the coordinates 60 comma 240. In the sense 60 units of product A and 240 units of product B are manufactured to get a maximum profit of rupees 1020. Thank you. Thank you.